Hello and welcome to my quick presentation of a different types of infinities. I will talk about different types of infinities, George Cantor who invented them, and how infinities can be seen and heard in different sizes. First, few quick things about George Cantor. He was a German scientist, mostly mathematician, who was born in 1845 and died in 1918. He was a brilliant man who was very interested in different types of infinities, and he had very brilliant idea of how to compare them. Before him, mathematicians were very afraid of infinity because, well, obviously it was very hard to comprehend and they really didn't understand how to use it or count it. So, George Cantor had this perfect idea about that instead of looking infinity as, this just number or odd symbol, he would look it as a size of a group. As you can see, here we have few groups. This group has size of a 4 because it has 1, 2, 3, 4 parts. And this group has size of 6 because it has 1, 2, 3, 4, 5, 6 different numbers. But George Cantor didn't stop there. He took groups which had infinite number of parts. Here we have normal numbers from 0 rising to the infinity, and here we have all square numbers 1, 4, 9, 16, 25, 36. And he started to compare these groups in a way so that he would find anyone a pair. So 0 and 1 make a pair, 1 and 4 make a pair, 2 and 9 make a pair, and so on. And here you can see that everyone has a pair. Therefore, these both groups are equal in size. They both are as big as other one is. So, he proved that there's just as big number of square numbers as there is normal numbers. But from here on, the theory gets a bit more complicated, and we will visit the Hilbert's hotel, which is every mathematician's favorite hotel. It has infinite number of rooms rising from 0 to infinity, and you will be the receptionist. And to make things a bit more interesting, every customer will give you a €1 as a tip. So, and before we start, you must know that Hilbert's hotel is full when you start your first workday. So, first day starts and there comes a customer. As you may remember, the hotel is full. But after a little panicking, you realize that there's still hope. You move customer from room number 1 to room number 2, customer 2 from room number 2 to room number 3, customer from room number 3 to room number 4, and customer from room number n to room n plus 1. This means that the room number 1 will be empty because there won't be anyone who's moving in there. So you can give the room number 1's key to the new customer and earn your first euro. Whippy! And so, next day comes and there comes also a bus. This bus is a bit bigger than the buses you are used to, because this has infinite number of seats, and therefore there's infinite number of customers in the bus. As you remember, hotel is still full. You panic a bit more this time before you realize that this problem can also be worked out. You move customer from room number 1 to room number 2, from room number 2 to room number 4, from room number 3 to room number 6, and customer from room number n to room number 2n. So you just move them to the room that's number is twice as big as the room they were before. This means that all rooms that have odd number as their number will be free, and now everyone from the bus can come to you and take a key. And you also earn infinite number of euros as a tip. Well, third day comes and it will be a lot harder. This time there's infinite number of buses, which each and every one of them has infinite number of customers. First, you panic a lot more this time, but realize that there's still hope. First, you just move customers as a day before, and after that, you make a list of the people in the bus. So that person who has seat number, so the person from the bus number 1 and seat number 1. So there's a bus's number and the seats number. And now all you have to do is to find an algorithm to go through this list so that every customer gets a, well, key. So you just follow the lines I've drawn, and every customer from this infinitely large list will be counted. So you earn infinity squared number of dollars. And as you may know, every number that it can be represented as n divided by m is fraction number, which means that we have at the same time proven that there's equal number of fraction numbers and normal numbers. And well, here comes the next day, and this day is a bit harder. Hotel is now empty, all the infinite number of rooms are free. And now there comes more persons. This time each and every one of them is thinking about an irrational number between 0 and 1. And every one of them is thinking a different one. So you start to think about it. Okay, this can't be hard. I've done one customer to a full hotel. I've done infinite number of customers to a full hotel. And I have done infinity squared number of customers to a full hotel. But this infinity is much bigger. As you can see, I've listed all the irrational numbers here and lined some of them. So to prove that this infinity is bigger, we just simply take the first number of the first irrational number, second number of the second, third of the third, fourth of the fourth, and the fifth of the fifth, and so on, and plus 1 to each one of them, each one of the points. So we get a new irrational number. It cannot be on the list you make, because its nth number is n plus 1 different from its nth decimal. So there is no such a thing as this irrational number in the list. So you add this irrational number to the list. But if you repeat this process, you'll find that there's also one new irrational number that is not on the list. You add it also on there, but you'll find a new one. And this goes on forever. Technically, there is no such... This infinity is so much bigger that you cannot find an end in this way or in any other way. So, because you don't manage to find room for infinite number of customers, hotel fires you, because, well, they don't get their money from infinite number of customers, and you may be a bit sad until you realize that you have earned during this time infinite plus infinity squared plus 1 euros in just few days. Congratulations! On a side note here, George Cantor, who invented this idea, was, well, very brilliant, but, well, got a bit confused after this point. He found out that there's also a bigger infinity than infinity of irrational numbers, but it's very hard to explain and doesn't fit into Hilbert's hotel anymore. So he got a bit confused and went crazy and tried to prove that Shakespeare didn't write his own acts. And he died in 1918. Thank you for watching.